Yesterday we have seen some date functions. So whenever you're dealing with your dates, calendars can be adjustable according to business requirements that arise. So whenever you want to go for the sake of calendar adjustments, we don't do it bluntly. We have a specific standard as far as the real-time constructs are concerned. So we start making use of the compositions of your round and truncate functions, which will take the decision how exactly your calendar should be corrected. Now whenever we deal with your round and truncate functions, generally these functions are useful only for the sake of number data type. But when we are passing the date internally is a number. That's the only reason these functions can start reacting to the process, and Oracle has overloaded these functions in such a way that when you pass the dates, it will take the correction to the process with respect to the nearest day or nearest week or nearest month or nearest year. That's how the process will be moving on. Now whenever I'm working on these particular functions with round and truncate on dates, I would be changing my clock and my calendar very regularly. Now through the control panel, whenever I am making a change, I will be just putting up the change in the process. And you need to recognize the date that's running in the clock, and along with that how the change or how the correction is taking place. Now a simple suggestion here is, if you are having any licensed software in your personal machines, you better don't try to do this. Why? Because if you are changing your control panel, there is a chance of your licensed software not to work. They may just lose their licensing patterns now, okay? So some things when I am working on dates, if you are trying to do it in your personal systems, that's your risk. It's not my risk. Be very clear about that. If I am working in my system, I will definitely take such a kind of care that my system is not going out of the process. But on your personal machines, you be very careful, especially the people who are having their laptops. Your operating system is definitely licensed. That's coming from your Microsoft. If you are going with date changes as you like in your particular clock, then there's always a chance your licensing process could be lost. And for people who are working professionals, almost as far as my knowledge is concerned, if your system administrator is very intelligent, he'll never let you make any changes in the dates that are existing in your control panel. If it is not restricted, and if you are attempting, think twice, because it could be creating some kind of information to the system at the back end for audit, that you are trying to change the clock of the server of the workstation, which could be a bad impact on your performance or say like your ratings. Now when you are just working with this, you just watch here. Currently my clock is running with Wednesday, December 18, 2013, and my time is 7:19 AM. Now I'm just going with select. I'm calling down my sysdate. And this is today. And then we are just calling down with round of sysdate. I'm not giving any parameters to this. Then we are going down with the process by saying truncate on the construct. And then you are calling sysdate once again. Then you are just trying to say truncated. And then we are saying from dual. If you just watch here, in both the cases I am not supplying any kind of arguments to these functions. If you have numerical data, definitely you have an idea that if you don't pass any arguments, it automatically eliminates a decimal portion. But in dates we don't have any decimal portions, so how exactly it's going to make a correction. Now you need to work on the outputs very properly, then only try to understand where my current date is 18th December 13. Round and truncate are also returning the same date. Now let us just make a small change in the clock. Where it is 7:20 AM that's running in my clock, I am making that AM become PM. So date is same, 18 December 2013, it is 7:20 PM. That's what we have changed. Now the moment my clock has changed to the post-meridian state, you can just watch the reaction of your particular round function. Round function has already corrected the date one day in advance to the next date. But truncate is always returning me to the same date. Means truncate always corrects the date and keeps the date to the same date. But round can always make the date get corrected to the same date or the next date. Now, how this is happening, we have to understand. Whenever you are using a round and truncate functions, they are definitely contacting the server. Within the server, if you are not giving any arguments to these functions, they are internally identifying whether you are having an ante-meridian mode or post-meridian mode. If any ante-meridian mode is there, then date is returned to the same day, but post-meridian mode on the clock is available, then the date is getting corrected to the next day. In both the cases, truncate is not making any corrections. Truncate is keeping the date to the same date what you have given. But round is definitely deciding whether the date should be to the same date or it should be to the next day. So it is all depending upon the clock activity of the meridian indicator. That's where you should always catch upon the issue. Okay, just make it know. When round and truncate is implemented, 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 upon the date, without any argument, the function contacts the server. And identifies a meridian indicator. Upon the actual state of the clock. The meridian is AM. The meridian is AM. Round returns the same date. The meridian is PM. Round returns the next date. In both the above cases, truncate returns. The same date registered or running in the clock. Okay, so that's your criteria with your round and trunk as a process. Now we are just going with a construct where I am giving my time once again to my AM, and then we are writing the same query you just got by passing the indicator as DA1. Now that is an argument what we can give for round and truncate as a process. So when we are trying to move with the construct and criteria, just when I am going with this particular day indicator into my round and truncate, you just watch the way it reacts now. Round is returning 15th December 13 and truncate is also returning 15th December 13. You just watch, these two dates are the previous Sunday. When date got corrected to the previous Sunday. Now, today is Wednesday and I am just trying to make a change in my clock. Once again you watch from AM to select PM. Okay, now we are on Wednesday actually. Now my clock was on AM, it was basically showing 15th December, there is nothing but the previous Sunday. Now we are once again on Wednesday only, but my clock shifted to the PM. So the moment my clock went into the criteria of the PM, and we are just going down with the process of running the query once again, you just watch, truncate is keeping the date only to the previous Sunday, but round has corrected the date to the upcoming Sunday. So here one thing what we are understanding is, the moment I kept my day indicator, My round and truncate are adjusting the dates to the weekdays. Weekday in the sense it's nothing but Sundays. Either it's the previous Sunday or the upcoming Sunday. Now how the logic is happening on truncate, we don't need to worry. Truncate always gives the date only to the previous Sunday. But when round is taken, round is considering the total weekday into two parts. It is dividing the total weekday into two parts. They are nothing but technically Wednesday before 12 o'clock in the afternoon or Wednesday after 12 o'clock in the afternoon. Means anything that is less than Wednesday before 12 o'clock, it automatically corrects the date to the previous Sunday. Anything that is greater than or equal to Wednesday after 12 o'clock in the afternoon, it automatically corrects the date to the upcoming Sunday. That's how it's making these adjustments. So exactly where I need these kind of constructs. In any financial and accounting management systems, these kind of compositions are definite. Be very, very clear about this. So when you get into your real-time constructs, you'll just try to see how exactly these compositions can happen. So only time tells you like exactly where these compositions can definitely help you. Just make a note. When day indicator is provided, when day indicator is provided, Oracle corrects the date. Oracle corrects the date with respect to the corresponding Sundays. Oracle corrects the date with respect to the corresponding Sundays. If the given date is less than or equal to Wednesday, before 12 o'clock in the afternoon, round returns the previous Sunday. If the given date is falling greater than or equal to Wednesday, after 12 o'clock in the afternoon, then it returns the upcoming Sunday. In both the above cases, truncate returns the previous Sunday. Now we are just going with the next level of the combination. Here we are just trying to specify month. The next indicator we can give is month indicator. Now when you are giving the month indicator, you watch the behavior of the round and truncate. It is correcting the date to the 1st January 2014, and basically truncate is correcting to 1st December 2013. Now since it's the last terminal month, definitely we may be having some confusion. Now I'll just try to keep my December to say like some October. Okay. My date is 18th only, but I'm having my month called as what? October. Now when you are deciding this, you just watch. Round is correcting to the 1st November. Means 1 month after. And truncate is always keeping the date to the first of the same month. Now here just let us go back by few more months. I am making it June now. Now when you are going with the June as a criteria, you just want, technically when we are running, round is going to give you 1st July 2013. And truncate is always returning first of the same month that is running in the clock. So this is what is basically happening. So here we can understand that when month indicator is given, the date is definitely getting adjusted to the first of some month. Either it is the same month or it is the next month. So where exactly this is basically happening, we should understand. And above that, you just watch carefully the round's behavior. Round is always taking my date to where now? The first of the next month always. Yes or no?
Yes.
Now I'm giving it on my December once again. We are on 18th today. Now from 18th I'm shifting it to 15th of this month. The moment my date is 15th of this month and I'm moving down the process, what's the behavior of the round? It is also giving you first of the same month. So here round is having one behavior. The behavior is, it is either correcting the date to the first of the same month or first of the coming month. If the first of the coming month is change of a year, it is definitely changing the year also. That date adjustments always have now. So year changes is always not a rule, but it is definitely making the correction to the first of the month. Either first of the month is the same month or it is upcoming month. In that way it's moving down now. So where exactly is doing? It is dividing the total month into two parts. 15 days each. Less than or equal to 15, first of the same month. Greater than or equal to 16, first of the next month. In both the cases, truncate is keeping the date to the first of the same month. That's how the logical state of the correction is working. Okay, just make it note. Whenever month indicator is provided, whenever month indicator is provided, month indicator are provided, Oracle is dividing the total month into two parts. Oracle is dividing the total month into two parts. Oracle is dividing the total month into two parts, 15 days each. 15 days each. If the given date is less than or equal to 15, the given date is less than or equal to 15, the round makes a correction to first of the same month. Round makes the correction to first of the same month. First of the same month. If the given date is greater than or equal to 16, the given date is greater than or equal to 16, round is correcting to first of the coming month. Round is correcting to first of the coming month. In both the above cases, truncate is returning always the first of the same month. Always the first of the same month. Always the first of the same month. Okay, that's your month-based correction, what your round and truncate will do. Now I'm giving a date to the same month and same date once again. Now we are making the last correction, where in the place of month we are giving the indicator as year. We are going with the year indicator. Now whenever you are going with the year indicator, you just watch the way it starts reacting, where your round is giving you 1st January 2014, your truncate is returning 1st January 2013. Means the date is getting corrected to the first of the current years. or first of the upcoming year. Now where exactly these corrections are taking place? You just watch. I am taking my December corrected to June. Now in the month of June, be very clear about that. Now according to when I am working in, you can just watch, the round is also giving you first of the same year. See, the question is very specific. Your round is, or round or truncate are correcting the dates the 1st January of the either same year or the next year. Round is always taking it to the next year when it is greater than or equal to July. The month running is greater than or equal to July. The correction is done to the first of the upcoming year. If it is say like anything less than or equal to June, it is done to the 1st January of the same year. In both the cases, truncate will be working on the same year. So these corrections highly influence your financial applications in real time. Just make it known. When the year indicator is provided, the year indicator is provided, the total year is divided into two parts. The total year is divided into two parts. The total year is divided into two parts. Less than or equal to June or greater than or equal to July. Less than or equal to June or greater than or equal to July. If the given date is falling, in the month less than or equal to June, the date is corrected to 1st January same year by the round function. 1st January same year by the round function. 1st January same year by the round function. If the given date is containing month greater than or equal to July, month greater than or equal to July, the date is corrected to 1st January next year by the round function. 1st January next year by the round function. Okay, next point. In both the above cases, truncate always returns. The 1st January of the same year. Okay, so those are the different combinations on which you have to concentrate when you are trying to deal with your round and truncate. Definitely expected questions from your interviewers, be careful. He'll give you any date between January 1st 4712 BC to 31st December 9999 AD, and he will tell you to make correction and tell what is the exact date that is about to fall. So when he is specifically trying to say that, how many number of times you remember what we have been discussing on the process and you work on. And let me tell you one thing very properly, if your luck favors, there could be anything around. If any good interview is being totally operated, then there are cases where if my project is very sensitive to the calendar management, only on dates, anything around 1.5 hour of interview could be there. So how many number of times you can manage your dates, that's up to you. So it all depends way, and dates are very dynamic to be composed. And anyhow we have been seeing only few of the aspects. Now we'll just try to check out where exactly the things can become more complicated by the time we start adding the conversion functions. Conversion functions are the most powerful functions, and they are most essential functions when you are trying to deal with your constructed criteria of your particular SQL. Not only Oracle, any SQL you work with, conversions are heart and soul of your application. So whenever you are dealing with your conversion functions, the conversion functions are always used to convert a value of one data type to another data type. At runtime we need to go for the sake of type changing. Maybe the programmers could call this process as typecasting. Now your typecasting in other languages to the conversion functions what we apply with respect to Oracle-like database or any database is same. Now whenever you go with typecasting or select conversion function or conversions, there are two kinds of conversions. One is implicit conversion, the next is the explicit conversion. Implicit conversion is always such kind of situation where your system can understand the data type and it can take a decision. But implicit conversion may not be successful always, because to what level your system can understand, to that level only it will apply the process of the conversion. If any data is beyond the understandability, the conversion automatically fails. So what exactly we mean by this? You just watch here, we are saying something like 1234. When if you just watch there, definitely that is in string. Then I am trying to say something like 4567, and I am giving this also in single quotes, so definitely this is also what no another string. But I am just going down with the process by taking this first string, and then we are trying to push down with the second string in the process. Now string plus string definitely should be a failure. I am just trying to say this is result, and I am saying from dual. Now when we are working in Oracle gets you the result. Means internally Oracle has made the implicit conversion here. So an implicit conversion was done, and relevant to that implicit conversion it's working. So be very clear about that. So on a technological perspective, when you are trying to work, it is the process by which this particular function will operate. It means implicitly Oracle understands where is a number and where is a string. This is definitely a string, no doubt, but technically each individual digit is representing one numerical component. Therefore it is able to do this particular job. Now here you just watch, I am giving some data with .00, let us say. And then I am just giving my next number also with a composition of .00. Then I am just making this also happen with .00. Decimal point is part of the number system. Your Oracle can understand the decimal point very effectively and will start working. Now the same kind of data you just watch, I am giving for our class. Generally when we write numbers for clarity we keep the group separators there like this. But actually group separators are not part of the number system. They are only for the sake of flexibility, and they are only for the sake of what? Convenience. So when we are doing this, Oracle cannot understand that it is a number, so it gives you an error. Means here Oracle is expecting that you should go for explicit conversion. So when implicit conversion is not able to get implemented, then we definitely should take into the process of explicit conversions. So explicit conversion is a responsibility by the developer when your system is failing through the process. What do you exactly mean by this? You just watch here. We are trying to say something like 18-December-13. This is definitely nothing but today. And I am calling my add_months. And we are just providing this 18-December-13, comma, we are saying 3. So we are just trying to say that add 3 months and get me the next part of the date from the system. So your add months is having ability of going for implicit conversions. For the same kind of select statement we are applying once again, where we are just trying to say the same 18th December 13, what you're having here, I'm saying plus 3. I just want to add 3 days. And we are just trying to go for the sake of from dual. Your operator called as plus cannot understand that this is a date. So it definitely gives you an error. So your oracle is saying that I'm unable to understand this as a date. So start implementing explicit conversions. So when the system is unable to understand, then it will definitely stop the implicit conversion and gives you an error on the process. And relevant to that state of the error, you should start up with explicit data type conversions. Explicit data type conversion is done with 3 different kinds of functions. One is your to-char conversion function, which is very clearly saying that it is always used to convert any data type into character. To-date conversion function, which is very clearly showing that you convert anything into the form of what? Dates. And to number is nothing but any kind of data you are having, and if it is acceptable to the numbers, then definitely you can convert that into what? No, numbers. Now whenever you deal with the construct, which function should be called where, you will be getting that exposure only by practice. But one thing you should remember, these functions can work to certain situations where the need arises. Identifying the need, recognizing the situation and working is your job. Now whenever you come to the process, to-char conversion function will come in 2 different kinds of flavors. One, to-char converting numbers into characters, to-char converting the dates into characters. Means any number, any date can be converted into characters. That's what you should finally understand. If you are understanding to-char function very properly, then catching up with your to-date and to-number will be very easy. This is just reverse of the process. You are neglecting yourself on to-char conversion function, then to-date and to-number will take time for you. I don't think I will be spending great amount of time with the to-date and to-number, because the major part of my requirement I will close with to-char itself. Now actually why we need these conversions in practicality first of all. Anytime we are having data, our data is definitely collected into the database servers. When we are collecting the data into the database servers, within the database servers, in the tables my data is always in valid state only. Because we are storing the data into the tables by keeping the information by process of a data type what we have declared. My table can never ever collect any data which is in the form of invalid state. Then where exactly the status of this particular conversion arises? That's where the application development process should be clear to us. So whenever you take any data that is operating through your databases, your data has 2 states. Your data is technically having 2 different kinds of states. One is the valid data. The next state of your data is invalid. Now when you are coming into the valid state, your valid state is once again of valid numbers. Means any number that is acceptable by Oracle by its architecture. So the numbers what you are trying to manage means anything like, suppose say this is a valid number. And then you are having anything like, suppose 2675.25. This is a valid number. This kind of numbers are valid, whether it's positive or negative, that doesn't matter. Then we are having the criteria and composition of your valid dates. Now whenever you are coming to valid dates, anything that is in the format of Oracle's identification, that is nothing but the valid. In the same construct you are having your invalid numbers. So whenever you are dealing with your invalid number, it is any kind of number what you are representing, let us say something like this with a group separator, or you are keeping any number which is having some symbol of currency where you are saying 1465 INR. It could be a valid number for you, but for Oracle it's an invalid state. The The same way you are having your dates where you are catching up your date by saying something like this. So when you are going to invalid date, your date what you are representing as, say like today's date you are saying it is Wednesday, you are saying 18 December and you are going for 2013 and you are trying to say AD. This is a very proper date for you, but for Oracle it's not date because it's unable to recognize its format. So when you are having any data with you, are you recognizing the state of the data first of all? So from valid state, you want to make any data get converted to invalid state because the client may request that he wants data in invalid state. In these cases, we always use the function toChar. So toChar function is a function that always converts valid data into invalid data. That is what is its job. So it can convert the data into two states, valid numbers into invalid character states and valid dates into invalid character states. So totally when it's in invalid form, Oracle considers that the data is in the form of what? Character only. Be very clear about that. Now there are many cases where we have the data in invalid state and we have to convert this particular piece of the data, say like by process of remember or by the process of do_date. So these two functions when we are using, we are converting invalid data into valid data. So this is general template what you should have in your mind when you are dealing with your basic conversions. Now where exactly these conversions will come into the picture, because we are definitely keeping the data within the database on the process and priority of internal table-like structures only. Now when we are keeping the data in the table-like structures, where exactly the situation of the valid and invalid comes in, because database never accepts any piece of the data that is in invalid state at all. So we are always collecting the data into the database from one specific location, that is nothing but the front-end end user. We are collecting the data and we are keeping the data from the front ends. So we are only database developers who are storing the entire data into your database servers. So within my database server, centrally that is available, we are always collecting the data only in valid state because of the data types. Means at any point of time your server never accepts any data in the form of invalid state. But we don't collect the data directly on the database servers. Actually the data is coming into these database servers from a front-end environment, which is nothing but an interface on which the end user is actually working. So we just watch it, this is our front-end interface. Now, still like I'm having some front-end interface like department number, a control item provided for entering the department number. Then I'm having the department name. You're having your location as a process. Then say like I'm having one column called as date of registration of this department. Which is taken from the front end. Then what is the minimum salary that is given to the employees in this department? Then we are having the maximum salary to the process. And maybe some other buttons. Now let me say that when my client is giving the data like this, department number 10, the department name is accounting. He's saying it's located in New York. Date of registration is giving this as Wednesday, 18 December 2013. He's giving the date like this. The minimum salary what is giving is say like 25,000 INR, and this is say like 1,50,000 INR. The client is saying that he will give the data like this, which is basically invalid state to the database. Database cannot accept it. So you cannot tell the end user, you please change your state, because end user says like that's more convenient for me. My employees can understand that only. So you can't have any other questions. The data has to finally come into your database servers from the front end, where the front end is saying that it will give you invalid data. And your back end is saying that I definitely want only valid data. Then we are dealing with the process and we are moving down through the issue where the back end is saying that it will always give only valid data. But front end says that you please give me the data in invalid state the way I gave you. Now in these cases, who will do these conversions as a secondary issue? If you are one of the person who has to do these conversions, you have to do this. You can't escape out of it. So this is the area where the conversion function should come and fit into the picture, where we just go down in a very proper way. So we are getting some invalid state of information and convert this to valid. So I'll be using to number, where I'll be getting the invalid number from there, from the front end. I have to put the format provided by my Oracle and I'll convert it. Then I'll be using to date conversion function. And I'll be getting invalid date, and then I'll be putting the format indicator provided by Oracle, and then it converts to valid state. From the database it's coming in valid state, so I'll call to_char. We are getting the valid numbers, and then we are moving down with the format indicator which converts the data into invalid state. We are having to_char once again. We are giving the valid dates to this. Once you give the valid date and you specify the format indicator for this, what is provided by Oracle, and it will convert that into invalid dates. So this is the area where you have to plan your explicit data type conversions as a requirement. will do this particular conversion, the process of the project will decide. If you are one of the person who has to do it, how effectively you can do it, that definitely depends on your practice and your practicalities. I'll be completing my process with TOCAD, but first I'll be working on TOCAD with number conversions. Then I'll start working on TOCAD with the date conversions. Now major part of the date-based constructs that have been pending, we are closing down on the process. So when you start working, do you remember your format indicators or not? That's very important. These format indicators you can always remember only when you are working regularly. Else the functions every student will remember, they are very simple to count, to number and to date. But internal format indicators only, they don't try to specify. Any format indicator you have forgotten, you are taking the time to apply the process by yourself. Now format models are what? They are nothing but some simple strings that are decided and that are defined by Oracle. These format indicators you have to always remember. By practice you can always recognize them. Now you just watch one of the format model I am starting is decimal indicator. Why we need a decimal indicator? You just watch the nature of Oracle. I am saying something like 1234.00 and I am saying number. Then I am saying something like 4567.00. This is num2. Then I am directly going with addition of these two numbers. You just watch carefully. Since the decimal place is not containing any specific identifiable numbers, your Oracle never returns once again the result with .00 to you. The result comes as only integer. But the end user is saying that if my integer is not having any valid state of value, then also I want .00. Means it's forcing that he wants a decimal point. In such kind of cases, you can always go for explicit conversion only. So you just watch, we are calling 2 underscore have, and then we are saying 1234 plus 4567. I'm adding two numbers where I did not mention any decimal places for them. But I want the decimal places. Now once I add these two numbers, what is the maximum size of the result I will be getting? Maximum number of digits in the result? 4 digits. So I am representing each digit and all format indicators should be in single quotes. So 4 digits of result will come 9999. That's my indication. Now I want a decimal point after this, D. How many decimal positions you want? 2 decimal positions, 2 nines, closer. So what I am telling my Oracle is, when these two numbers are added, I will definitely get a value that is basically of how many digits? 4 digits in real part, and give me a decimal point, and then give me 2 decimal positions. If the corresponding data is not having decimal positions also, Oracle will try to keep .00 for you. So we converted a valid state of a number into invalid state, because valid states doesn't contain .00s. You force the number to keep up itself with .00, so you are forced to do the process. Now here there are a few simple things you should recognize. So can I have these numbers more? You can have more numbers, no doubt about it. Now as the numbers are increasing, so many decimal positions will be increasing. Now that's one particular criteria. So keeping how many decimal positions is your choice. Now sir, can I have more numbers to this side? You can have more numbers on the left side also. As the numbers are increasing on left side, so many pads will increase, not zeros, remember that. So many pads will be automatically increasing. Now my number is actually 4 digits. So if I keep my number of pads less than 4 digits, what happens? Bound error will come, which we have already seen long back. So the format indicator should be either equal to or more than, but it cannot be less than. Be very, very specific to the rule. So keeping up yourself very clear, you can start working on the issues. Now when you are working in the place of this, you can even call it database oriented columns also. So what do you mean by this? I'm saying ename comma, I'm calling to underscore care of Sal. I'm just trying to say 9999 D99. This is my Sal. Then I'm calling to underscore care of commission. Then we are saying 9999 D99. And this is commission. Then we are moving down into underscore care of. We are saying Sal plus NVL of commission comma 0. And then we are trying to say 9999 D99. So this is my total Sal. And then we are just getting through the construct by saying from TMP. So your total data from your database is given with decimal points. Presentation is in decimal points. In reality in my database there are no decimal places. So we can just change the output of the report very easily without going for excess programming. So how you define and how you associate, that's up to you. Be very clear about that. So conversion function comes into the picture only when you feel that its essentiality arises. The same way, the next indicator what you are having is scientific notation indicator, which is 4 is what you should mention definitely. And here you just need to check what is scientific notation indicator. Now just watch these two numbers what I am keeping on my screen. Now this number is 10 digits exactly, and I am giving one more number which is 11 digits in the process. Now you just watch, whenever the number is up to 10 digits, Oracle represents as it is. If a number is becoming 11th digit, Oracle is converting that into scientific notation. Exponentiation is automatically coming 1.342346 into 10 to the power of 10. That's what it's trying to say. So what the end user may say is, even if my number is very small, I want that number in scientific notation. Means naturally Oracle can convert a number into scientific notation. But the client says that I want this number also to be in scientific notation. Means a number that can be naturally represented, it demands that number also to be in scientific notation. When he is demanding that number in scientific notation, then we are forced for scientific notation. Naturally it's not happening. So in such kind of cases, we will call the construct of toChar once again, to underscore char. And this is a number what we have. I have to tell this number, convert the process into scientific notation. So I am saying 9.9999 EEEE. So I am very clearly saying that to that particular convention make a conversion. 1.2346 into 10 to the power of 9. So this is natural conversion by Oracle. This is forced conversion by us. Now how many 9s you should keep, that's up to you. You keep only 2 9s. It will evaluate the decimal positions up to 2 9s. That is 2 positions. Therefore you should keep how many on the right side, it's up to you. Your accuracy. So generally Oracle gives accuracy up to what? 4 places. Now you can also follow up to 4 places. And you are trying to say 4 is definitely you have to declare, then only you will understand that it's a scientific notation. So we can force any number into scientific notation by making use of the scientific notation indicator. The third is group separator. Now whenever you are dealing with group separator, it's something like this. You just watch, we are having something like select 1234.00. This is number. Now for my convenience, I kept the number like this. Now technically I am working with 2000 select 345.00. This is my second number for my convention. Now what I am doing is, I am trying to say, I want the result of 1234 plus 2345 345, which is nothing but the result from dual, where I want group separators. Oracle never gives you any group separators by itself. But client is saying that I want the result in this type. He is saying that I want the result with group separator plus the decimal. One number can have only one decimal point or multiple decimal points. One decimal point. One number can have only one group separator or multiple group separators. Multiple can be there. According to the common sense only you can use your conversions. So you just watch here, we are saying 2 underscore charo. I'm adding these two numbers. Now you just watch the way I'm keeping first 9999 D99. That will give me decimal indicator. Now from the right side I'm catching up. After the first three numbers I want group separator. Now keeping group separator where you want is your choice, because universally we don't have a rule like group separator should be here only. So once you gave that, Oracle can understand your request and it will come up with the group separator. So any number of group separators can be given. Group separators have no logical state. Means I am giving my G everywhere. It gives me the group separator with every number. But decimal indicators cannot be repeated like that, because one number can have only one decimal place. So group separator representation is your choice. You just watch everything. ename, comma, 2 underscore charo, sal, comma, 9G999 D99. Then we are going with 2 underscore charo, I'm saying commission, comma, 9G999 D99. That is commission. Then we are going with 2 underscore charo, we are saying sal plus NVL of commission, comma, 0. And then we are trying to say 9G999 D99. This is total sal. And we are working with from dual. So whenever from here, okay. So that's your EMP table, and we are moving down with the consoles. So all my salaries and my commissions with the group separators and decimal indicators along with the total salaries. So I think we are giving a better presentation to the end user the way he is demanding from us. I don't think anywhere we have any extra coding or extra programming what we are trying to. Simply with functions we are making the state of the data to change. Now the next basic indicator what we have is locale currency indicator. Never the data in the database is stored along with the currency. I am making my point very clear. We never ever store any data at any point of time within the database with the currency. Currency is only a presentation logic and manipulative logic. But the end user says that I want to see the currency in my output. Then there are multiple indicators. One we are seeing now is locale currency indicator, which is used with L, where L can be a left side indicator or it can even be a right side indicator, means leading or trailing indicator. Any side you keep. Whichever side you keep, L currency will shift to that side. So the default currency that is returned by Oracle we need to check first of all. So you just watch here, we are going with 1234.00 and say like I am trying to say dollar. This is number. Then I am going with 2345.00, another dollar, and we are saying num2. Now we are going with 2 underscore charo. We are saying 1234 plus 2345. Now the result is definitely 4 digits. So I am saying 9G999 D99, and then I am saying L. I am not mentioning anything on the process, but I am saying result, and I am just trying to say from dual. Now automatically you can just watch my dollar sign comes to the right side.